for the recording banner to pop up.
Yeah, hopefully it'll pop. There we go. Cool.
Awesome. Thanks, Jason, and thank you all for having me. I wish I was really in Boston. I really like the city of Boston, but this will have to do for now, and maybe at the next meetup next year or something, we can do it in person. So yeah, as Jason mentioned, I'm a program manager on what's called the ARM deployments team. So ARM core, the ARM API that kind of backs Azure, is broken into a few sub-teams. And one of them is this deployments team that's responsible for all the native declarative deployments to Azure. So that includes the things that Jason was mentioning, blueprints, ARM templates, this new Bicep project, anything kind of adjacent to that. There's capabilities that we've introduced, like deployment scripts and what if. All of that comes out of our team. And today we're obviously talking about Bicep. We'll do the overview. We'll do kind of give you a sense of where the project is at, like current status, what release we're at. We'll do some demos, and then we can talk about future roadmap. But please interrupt me as much as possible. These are more interesting when I get interrupted. So whether you want to ask questions in the chat, I'll have the chat open, or if you want to come off mute and ask that way, either works for me. So let's get started. Let me move this slide here. I'm not in presentation mode. I'm not usually on this monitor. It's one of those ultra widescreen monitors, and I'm just presenting the window, and I don't know what's going to blow up if I go into presentation mode. So we're going to stick with this one for now. So to start out, what is Bicep? Are most folks here familiar with ARM templates? Maybe a virtual raised hand or something in the chat if you do have some experience. ARM templates are just a way of deploying Azure resources declaratively, is what we say. So basically, you describe in your ARM template your goal state, what you want the X number of resources you have in your template to look like when the deployment is done. Sometimes we describe that as taking care of the what versus the how. So you, with an ARM template, just describe the what of what you want. You don't have to be responsible for how that actually takes place. You don't have to care if the resource exists already or not, is the idea there. With Bicep, it sits on top of ARM templates. Bicep is most literally a transpiler. So it takes Bicep code and it turns it into ARM template code. And at that point, it's just a regular ARM template. There's some extra metadata littered in there, but for the most part, it's just a regular ARM template. And that means that anywhere where you can use ARM templates, you can use that with Bicep generated ARM templates. We have this command in the Bicep CLI, which I'll show, which is the build command, which is what literally takes you from Bicep to ARM templates. But we do a bunch of things now to basically force you don't have to see the JSON if you don't want to, or the ARM template if you don't want to. So when you're deploying or creating deployments to Azure, you can use the Bicep file directly, and when we see that, we know to turn it into the JSON ARM template before actually sending it to Azure to be deployed. But at the end of the day, there's always an ARM template involved. If you're familiar with the relationship between TypeScript and JavaScript, it's exactly the same story here. Why are we doing this? What's funny is, before we started this Bicep project, ARM templates were certainly not the most desirable tool to use. And I think we lost quite a bit of mind share in terms of people thinking ARM templates was a good or a helpful tool to use. But the reality is that they are by far the most widely used tool for doing these declarative deployments to Azure. And that's comparing tools like Terraform or Pulumi or Ansible or things like that. Those are what we consider to be the declarative tools. ARM templates is the one that is most commonly used. And so really the point of the Bicep project is to lower the kind of pain levels and the barrier to entry for customers that would otherwise or are using ARM templates. So if they're already using ARM templates, we definitely have an interest in getting them over to Bicep, because their experience generally is better. But also for you all, or if you're a consultant and work with customers, for customers that are transitioning between the portal to infrastructure as code for the first time, I think in the world that we're in, and going to meetups and being really active in the community, we tend to think that infrastructure as code and kind of modern deployment practices are very common or universal. But the reality is that there's a long way to go in terms of maturity. So there's a lot of users of Azure or the cloud more generally that just haven't made that transition yet. And at that point, we want Bicep to be a great tool in the sea of options that you have for deploying to Azure. This is a better way of saying why we're doing this. So this meme circulated on Reddit, I guess closer to 2 years ago at this point. Just saying, Azure's awesome. There's all these services that we make available, and we're constantly iterating and coming up with new things. But ARM templates leave a lot to be desired when it comes to accessing those capabilities. So our goal is really to make this dog happier and not have to deal with these gnarly functions. I'll talk through the benefits, like I said, and then talk through the state of the project. So don't worry about paying too much to the literal syntax on the left and right hand side. The important bit here is that the left hand side is Bicep code and the right hand side is equivalent ARM template code. And this really speaks to one of the first benefits, is just that the code is a lot easier to read. It's much terser. There's no what we sometimes call JSON noise. The kind of biggest challenge with ARM templates was that we kind of had to stuff the ARM template language into JSON, and it had to be a valid JSON document. So all of the ARM template language, if you have experience with it, anywhere where you're seeing syntax highlighting inside of these open and closed square brackets, that's the actual ARM template language, and it's inside of a JSON string value. And all that really means that it just makes it all much more difficult to offer good tooling. It makes it more difficult to do good validation, good IntelliSense, all these sorts of things that we expect from modern programming languages were really kind of fundamentally difficult because we had to fit inside of a JSON file. So with Bicep on the left-hand side, we have our own file extension. We have a very deliberate syntax. There's none of this extra noise, and that just ends up making the code a lot easier to work with on a day-to-day basis. Day zero support is the next big benefit, and this is just as true of ARM templates as it is with Bicep. So both ARM templates and Bicep are a very thin abstraction over the ARM API. And what that ends up meaning is that as resource provider teams create new resource types or new API versions of existing resource types, all of it kind of just works in Bicep and with ARM templates. There's no onboarding step that these teams need to take beyond what they're already doing to make things work properly in Bicep. That's great if you are on the bleeding edge and you want to take advantage of the new Azure Orbital service and push satellites around or whatever that service is for. But where it ends up being more important is new API versions of existing resources. So if you're using virtual machines or websites or what have you, there's new API versions of those services all the time. And they usually contain a new feature that you may want to take advantage of, or a critical bug fix, or what have you. And so being able to consume those new API versions when they're available ends up being really valuable. The next big one is a first-class modularity and code reuse story. This is one of those things in ARM templates that technically you could do, but was really difficult and really error-prone and very much like a duct tape and glue kind of solution. It was not well considered when ARM templates were created. And so this was just a tricky kind of thing to get right with linked templates where you had to stage files to a storage account. Some of you may be familiar with that process. Pretty gnarly. With Bicep, we have a very straightforward modularity story that should feel familiar if you've used kind of any modern programming language or scripting language. So if you're familiar with PowerShell modules or TypeScript modules or Terraform modules, they all happen to be called modules, but there's code splitting strategies and features in any programming language these days. So this is much closer to that than what we had previously. And this one is probably my most important point, or the one I'm most passionate about, is that Bicep was really built for toolability from the start. It has really, really good IntelliSense and validation. And the context here is that when we worked on ARM templates, there's a VS Code extension called ARM Tools. And like I mentioned earlier, we've been forced to fit into a JSON file really fundamentally limits how much you can do in the tooling space. And so when we started Bicep, we really knew that we wanted to focus on this, that this was really important. But we had no idea how to do this. And so we consulted with some language design experts here at Microsoft that we are very blessed to have access to. So C# was designed at Microsoft, but you may not know that TypeScript was also designed at Microsoft, in part by the same person that we've had an opportunity to talk to. His name's Anders Heilsberg, and he gave us a lot of really good insight into how you make a language toolable. And he gave us really, really excellent advice, and we were able to kind of build on that. And that's all a really, really long way of saying that the tooling experience is great, and it feels much more like a traditional modern programming language than a declarative config type language. It shares a lot of DNA with how those modern programming languages are built. So even though it doesn't look like a traditional programming language, it feels on a day-to-day basis like a programming language in kind of the best way. The next benefit, no state management. So if you are using Terraform or Pulumi, those tools require you to have this state representation. Because they work not just with Azure, but with a whole suite of providers. And so they need some representation of what those providers look like, and they do that with this concept of a state file. With Bicep and with ARM templates, we use Azure as the state. So if we ever need to get information on a particular resource, we do a GET request on that resource ID, and we get the latest information. So there's no need to have a state to track. And we can have experiences like what if, where you can predict what the deployment is doing by querying the current state of the resources, whether they exist or not, and whether that state matches the state that you're going to submit with the ARM template. And so if you submit your Bicep code to Azure and then throw your laptop off a cliff, you've already sent what we need in order to carry out your deployment. So that will all finish versus some other tooling that does that all client side. So goals and non-goals. Goals I kind of spoke to with the benefits. So certainly we want to lower the barrier to entry and improve validation as much as possible. We want to be that transparent abstraction where you can leverage the entire platform, and we want to be modular so that you can make sure your code is maintainable over the long run. And then the non-goals, we don't want to be one language to rule them all. So we don't have any kind of intention of saying the only good way to deploy to Azure is with Bicep and all the other ways are bad. Like I mentioned earlier, with Bicep, we just want to be a great option in a sea of great options. So we invest a lot to make sure our Terraform provider is really capable. If you want to use PowerShell or CLI to do your deployments to Azure, if you want to use the portal to do your deployments to Azure, all of those are valid. It just depends on what your use case are, what your scale looks like, and so on and so forth. So we really just aim to make all the clients to Azure as good as they can possibly be. And then Bicep is not a general purpose language. So if you need to do a lot of number crunching or data processing or transformations or things of that nature, you may find that you still need to write a PowerShell script or a Bash script to do some of those things in a pipeline, either as a pre or a post action or something of that nature. Cool. So this normally animates, but I'll just get right to it. So the project is about a year old right now. So we had an 0.1 and an 0.2 release that we got out really quickly. And that was just to get it out there and to get feedback and to get people's reactions on the goals of the project. And it wasn't really until our 0.3 release, which was in March of this year, where we declared ourselves production ready, that Microsoft support would take support cases for Bicep issues, and that we had parity with ARM templates, so that anything that you could do in ARM templates, you can do in Bicep. And right now we're kind of in the later stages of our 0.4 release. So that the 0.4 release has been out for a little while. We've done a few kind of releases within 0.4 to ship some new features. But really the focus for this one has been on quality and stability. So there were a handful of bugs that emerged with 0.3 or on our way to 0.3. And as we've seen a kind of big increase in usage post-production, we've really just wanted to make sure that things continue to be stable and usable. There are a handful of other features like speeding up the inner loop with a linter that I'll show today. And then we just this past Friday, and I'll demo this as well, introduced a private module registry so that you can share code not just within your repo, but you can set up kind of a central source that people can pull from, a la NuGet or NPM, that sort of thing. Any questions? I'm about to go into a demo, but this is a good time to stop and any clarifications or questions I can answer. Okay, then I'll keep going. So let me stop sharing this window. Now I'm going to share a different window. You all able to see this?
Yeah, I can see it good.
Cool. Let me make it a little bigger. I'll hide this for a second. Okay, so I'm in VS Code right now, and I have the Bicep extension installed. So you can, and actually let's update it to the most recent version. We'll do this live. So like I said, this came out on Friday, and so I happen to have not installed the most recent update. But you can go into the VS Code extension tab and install it today. It's all public. And then once you've done that, VS Code will recognize the Bicep language, and that just means that the Bicep extension, or what we sometimes call the language service, is running and providing assistance and validation to you. So what I'll do is just start by authoring a really basic kind of raw resource declaration. So I'm going to author an app service plan or server farm. It's gone through many different names at this point. So we'll call this an app plan. So we have a resource keyword, and then we have what we call a symbolic name. This is like a variable name. So I could have called this foo. I could have called this my app plan. I'm just going to call it app plan. And you'll see where this is useful in a second. And then it's going to ask me what type of resource I want to create. And this is when we say transparent abstraction, this is what we mean. So all the different resource types and child resource types and API versions, they're all represented here in this very long list. And this is all the things that Azure and ARM exposes. Now I can filter this list down just by typing, and I can search for server farms. And if you didn't know, at the API level, an app service plan is actually called a server farm. So this is the kind of information you need to know if you want to use ARM templates in Bicep. And then I'm going to pick an API version, and 99 times out of 100, I'm going to pick the most recent API version, unless I have a reason to pick an older one for some reason. So I'm going to pick the most recent one. And the reason that we have these API versions is so that the Bicep code is maintainable over time. So as the resource provider ships new API versions, there's a commitment from Microsoft to maintain these older API versions for a long time. So you should be able to leave this code alone, come back to it a year later, and the behavior should not have changed. Sometimes things slip through the cracks and breaking changes get into old API versions, but that's the exception, not the rule. And the reason that you pick an API version for each resource type is because these resource providers are all different teams. It's a completely distributed system. And so if one team revs their API version, it has nothing to do with another resource provider revving their API version. So you want to, generally speaking, keep these separate and contained to the resource types that you're using. So now I'm going to do equals, and then I'm given some options to kind of make writing certain scenarios easier. So I have options for doing loops or conditional deployments and things like that. I can insert all the required properties, or I can just do an empty object, which is what I'll do for kind of pecking out the whole resource so we can understand kind of how that works. I can do control space at this point, and I can see all the top level properties that the server farm resource makes available. So I need to provide a name and a location. So I'll say this is Alfran app plan. And for the location, I'm going to use the location of the resource group. So in Bicep, we expose a library of built-in functions. These are the same functions that you have access to in ARM templates, if you're familiar with those. I need to set a kind, which is going to be Linux. I need to set a SKU, which is going to have a name property, and the SKU in this case is going to be B1. You'll notice sometimes, like when I did kind here, I got no IntelliSense options. And the reason for that is because the API specification that the web team publishes with their API does not have that information. So going back to us being a transparent abstraction, we are at the mercy of the resource provider for making sure that they specify their resources correctly. I'd say web is more of an exception than the rule in terms of resource types doing this correctly. So we're working with the team to get this updated. In most cases, the values are pretty accurate, and you'll get IntelliSense as you're typing through all these things. But for server farms, you have to know a little bit more than you otherwise would. And then I need a property called reserved. So these are all the properties that are exposed for this API version. This is actually just a great way to explore what the resource type offers. But in this case, I just want the reserved property, which lets me make sure that it's going to be a Linux app service plan. Now, everything's hard coded. This is not kind of a typical way I would author a resource. Normally, I'm going to author some parameters to make the code a little bit more dynamic and useful for a broader set of use cases. So I'm going to author a parameter. I'm going to call this name prefix, and it's going to be of type string. And we can see here I get a yellow squiggly telling me that the parameter is not used. That's the linter doing an extra set of checks for me to make sure that I'm doing what is expected. Even though this code will deploy, it's probably not what I intended. I do want to use this name prefix. So what I can do here is do string interpolation. So this should look familiar if you've done string interpolation in other programming languages. This is the equivalent of doing the concat function in ARM templates. So it's just a less verbose way of describing that. If I wanted to set a variable or another parameter, I could do that for something like the SKU. So I may want to say the SKU, which is also going to be a string, and I want it to have a default value. So with parameters, if you do equals, That's the default value of the parameter. And so that just means that when the code is deployed, I don't need to input the SKU necessarily. So I can do SKU here. I also have the ability to set variables. So I may want to do var kind equals Linux. And I can just replace that with kind here as well. So you have a set of different things to help you make the code more dynamic, and variables can help you reuse code just like they do in any other programming language. And then the last thing I'm going to do on this file is set an output. So for most of these resource types, you want to get information either out of the module, which is what we're going to do here, or you may want to read that from the deployment itself to get some output in a pipeline that you use somewhere else in the next task in your pipeline. So in this particular case, I want to get the server farms resource ID, because we're eventually going to create a website that sits on top of this app service plan, and we're going to need the resource ID. So I'm going to do output is the keyword in this case, and I'll say plan ID, also going to be a string. And then here's where we get to use this symbolic resource name for the first time. So we have this thing called app plan. It's different than the actual resource name. It's just for referencing inside of the Bicep code. So what we're going to do here is say applan.id in this particular case. If I needed another property from the app plan, I can go to properties and I can look at all the properties that they make available. And this will include read-only properties, properties that you can't set when you're creating the resource, but do exist when the resource is created. And so Bicep understands that distinction and will show you the right list at the right time. But like I said, in this case, I just need the ID. And now I have a complete Bicep file that will deploy the server farm that we're going to consume as a module in a second, but I will stop and take any questions if there are any. Any questions on the code that we've walked through so far? Any clarifications, or hopefully I'm just being incredibly clear?
The only question I have as I see you typing this is there something where I can take my existing ARM templates and come back to Bicep, so that, because this definitely looks like a lot cleaner way to store my scripts versus the ARM templates that are just have so much junk in them.
Right. Great question. So there's a couple different things that you can do with your existing ARM template code. One is you can use a command we have called decompile. So you can do Bicep decompile, point it at an ARM template, and we'll convert it to Bicep for you. It's machine generated code, so it's not going to be perfect. Your variable names might be a little wonky and things like that. But it should be working Bicep code at that point. So that's one option. The other option is with modules, and I'll show this in a second, is you can consume Bicep code in a module, or you can actually point this at an ARM template. So if you don't want to go whole hog and convert all of your code to Bicep all at once, you can author a Bicep file that's kind of like an orchestration file that pulls in your existing ARM templates, and that can be kind of like a half measure to getting started with Bicep without having to convert everything all at once.
Awesome, thanks.
Mm-hmm. Any other questions? Okay. So the next thing that we will do is create a file called main.bicep. And actually, let's show off the decompiler. So this is decompiled code, and I will sometimes demo this. So I have this folder here that has an ARM template. It's a regular ARM template. There's nothing special about it. It deploys a website, and it deploys a container-based website that exists in Docker Hub. What I can do is do AZ Bicep decompile. So Bicep is built into the Azure CLI now. So you can call the Bicep CLI and do things with it from the AZ CLI. AZ Bicep decompile, and then we'll point it at this site.json file, and it will spit out site.bicep. And I'm getting some warnings saying, hey, this is not perfect. If you run into issues, you can file these in our GitHub repo. Bicep is an entirely open source project, so we have a pretty active community over there, and we definitely encourage participation, filing issues, all that sort of stuff. So now I have my converted site.bicep file, and it'll do things like take advantage of features like string interpolation and things like that. So I'll move this over here just so it's easy to get to. And now what we'll do is author a main.bicep file that will use these other bicep files that we're creating so that we can just kind of orchestrate the deployment together. So we're going to do a couple things. One is we're going to set the target scope of this particular file to be a subscription. By default, it's a resource group. Most deployments target a resource group, but increasingly we're seeing people deploying their templates at higher scopes and doing more complex orchestrations. So we're going to target the subscription, and the main reason for that is because we're actually going to create the resource group as part of our deployment. So I'm going to say resource again, and I'm going to call this RG, and I'm going to search for resource groups. That's the type that I want. And I'm going to use the most recent API version, and then I'll do equals, and then I'll just let Bicep fill in the required properties for me. So I'll call this Alfran RG Boston. And then for the location, I'm going to use a function called deployment, which exposes a location property. So I don't need to hard code the location here. And then I'm going to start consuming the module. So I'm going to say module is the keyword in this case, and I'm going to call this app plan deploy. And then I get IntelliSense to see all the Bicep files that I can consume as a module. So I'll say applan.bicep, I'll do equals, and then I will skip the required properties and do that myself. So the module needs a name. So I'm going to say name, applan deploy. This is not the name of the underlying resources. This is the name of the module. So yeah, not super critical, but good to be aware of. And then what's interesting here is this app plan Bicep file is designed to be deployed to a resource group. So I can't deploy an app plan to a subscription. I must have a resource group. And if I hover over this, one of the things that it's going to complain about is that it's missing the following property scope, because it's saying this is not valid where you want to deploy it. You need to give me something somewhere else to deploy it to. So I'm going to set this property called scope, and I can see that Bicep is telling me that it's one, it's required, and two, it's expecting a resource group as the value of the scope. And what I can do very simply is just say RG. I can say this is the resource group that I want you to deploy to. It's another use of that symbolic name that we have. And then the last thing is the parameters. So these are the parameters that we set up previously, and it will know which ones are required. So we have our name prefix and our SKU. SKU has a default value, so I don't need to do anything if I don't want to. But name prefix I do need to set. So I'll just say Alex here is my name prefix. And so very simply, I can consume a module, fill in whatever required parameters there are, and the business logic, the hard part, has been done for me, whether I'm the one who authored that code or someone else made that code available to me. And then the last one we'll do is another module to deploy the website. So I can say another module and then site deploy. I'm going to consume site.bicep, but I could also go and consume the ARM template site.json, and this would really work just as well. So if I didn't want to convert it, I can use my ARM template instead. But I would like to use the Bicep file, and we can fill in the required properties automatically, and then I'll go through here and fill out the RG scope, because again, I'm going to deploy the site to a resource group. The name, so I'll just call this site deploy. the app plan ID. So this is why we expose that app plan ID in the other modules, because we need to say for this website, it's going to target this app plan. So what I can do again is take advantage of that symbolic name and say app plan deploy, do dot property access. In this case, I want to get the outputs of this module. And then if I do dot again, I see that that plan ID is there, and that's expected because we made that output available. The Docker image happens to be called nginx demo/hello. The tag, we're just going to do the latest tag. And then I need a name prefix for the website itself. And so I'll just say Alex for the name prefix there. And so in a very straightforward way, I can bring all these code samples together with modules and tie together kind of a larger deployment in this kind of main.bicep orchestration file. One thing that, if you're familiar with ARM templates, you probably have some painful memories of that we didn't see in this demo is the depends on property. So in ARM templates, you had to know what had to be deployed first, and you had to set all those dependencies correctly, and that was a really error-prone exercise. With Bicep, in most cases, you don't need to set dependencies anymore. So we can know, because of references like this, that the app plan must be deployed before the website. And so you don't need to manually author the app plan or the dependency to the app plan module. We'll just set that for you automatically. Same with the resource group. So we know that the resource group has to be deployed first. And just to check my math, we can actually visualize this code. And this is kind of like what the Bicep language service is seeing at any given point. And we can see that it understands that there are some modules here. The directions of the arrows is a little confusing, but what this is saying is that the resource group needs to be deployed first, and then the app plan can be deployed, and then the website itself can be deployed. So this can be a useful tool for kind of understanding how the Bicep language service is processing your code. Any questions? That may have been a lot.
So I have a quick question.
Yeah.
So you said that there's a transcompilation involved. Do those files actually ever exist, or are those done on the server side and we wouldn't see the ARM templates?
Good question. So the Bicep code needs to be transpiled or compiled into an ARM template client side before being sent to ARM. So the ARM service still only understands ARM templates. But what happens is if I do AZ deployment group, or in this case, it'll be sub create, this is the regular deployment command, no changes to the structure of this command. And then if I point it to a file, I can point it to my main.bicep file, and it will transpile it in memory, send it to Azure. So I will never see a JSON file on my local machine. It'll all happen in memory and get sent to Azure. So you generally just don't need to worry about it, but it is always happening client side under the covers.
Okay, cool.
Any other questions?
I have a question on creating resources across subscriptions or accessing items from other subscriptions in the code. Looks like you have to set the scope at the beginning, but if you have resources that need to be either deployed or accessed across subscriptions, how do you do that?
Yeah, great question. So if you need to get a reference to an existing resource in another subscription, or in general, for scenarios like I need a secret from a key vault, or I need a reference to a container registry, or some of these like centrally managed type things, you can use a feature called existing. So we'll do it in our app plan file. We'll get a reference to a key vault. So I'll say resource, and I'll say existing key vault, and I'll type key vault. Pick the most recent API version, and then I will add this keyword called existing. And when I set existing, the only property that I need is the name. So my existing eVault, which if it's in the same scope as the target of your deployment, you don't need to set anything else. But if you do have that resource in another subscription or another resource group, you can set this scope property. And you can use a function called resource group. And this has actually a few different function signatures. One with just the resource group name, if it's in the same subscription but a different resource group. Or you could also pass a subscription ID if it's in another subscription ID. So you can say this is my sub ID, and this is my RG name. And so you can provide that information, and this will translate to a reference to that existing resource. Does this make sense? I know I have another part of the question to answer, but so far?
Yep.
Cool. If you need to deploy a resource to a different subscription, the only way to, what we say is cross a scope boundary. So if you need to escape out of the scope that you're currently in, you do that with modules. So just like we declared the scope of this module to be this resource group, I could instead say, I don't want it to be the resource group we created. I want it to be a resource group in another subscription and another resource group. And so as simple as that, as long as it's in a module, you can target that module to any scope that you have access to in Azure.
So you have to create a module first. You can't just create a resource in another subscription.
Yeah, you can't say resource and do something like this. You can't say scope here and then point it somewhere else. We aspirationally would like to be able to do this, but you can't do it today.
Okay, thank you.
Any other questions? One thing that I have not demoed is the ability to do loops or conditional deployments of resources. So you can do things like, I guess I can just demo really quickly. Should deploy site is my variable, and I might say it's true or false. Let's say false in this case. I can do something like this pretty easily and say should deploy site. And now this deployment is going to only be done based on the value of this condition. So you can use parameters or anything like that to set the value of this Boolean, which will determine whether the thing will deploy or not in this particular case. The other thing that you can do is iterate and do a loop to create multiple resources. So if I created a variable called sites and it was an array of objects, I need the website to have a name. So we'll call this fancy and we'll give it a tag, which is latest. And then I want to do another one, which is plain, and the tag is going to be plain text. So now I have this list of things, and I want to use that to create a set of resources. So what I'm going to do is add this bracket statement. So I'm going to say for site in sites, and I'm going to add one more bracket here. Now I have this site iterator that I can use to make sure that each iteration of this website is unique. So one thing I want to do is say site.name here so that the deployment name is unique or the module name is unique. And then the other thing I want to do is use site.tag as the tag for my Docker image. And I'll use site.name as my name prefix. And so now I can create n number of websites really easily. If you're familiar with ARM templates and the copy property, this is the equivalent of that in Bicep, but hopefully it's a little saner and easier to read and easier to manage. And of course, this list of websites can come from any source. This can come as a parameter. We have a function for loading text content. So you can load in a JSON file as part of your Bicep project. So if you have a list of subnets and IP addresses and things like that in a JSON file, you can consume that pretty easily with this function called load text content. So just some of the ways that you can make your code that much more dynamic depending on the scenario that you have. Any questions about some of those more complex expressions?
I think you somewhat just answered it, but we use a lot of, we're in Terraform place, and we reference what we call like a subscription default, which would have, you know, a ton of outputs that's used in other parts of our code. So that mechanism you just explained, would that kind of be somewhat of the equivalent of like trying to get all your dynamic like subnets from like your subscription network defaults?
I think so. I want to make sure I understand the scenario before I say yes. Is the idea that I have a set of like constants that I'm referencing throughout the code?
They're mainly constants, but like I have code, like say I'm creating a landing zone that has like my network. So I have a VNet and it has 5 subnets on Monday, and then Tuesday I create a 6th subnet and that output changes. If somebody wanted to reference that 6th subnet in their code, they've already would have had that TF state file loaded into their Terraform code. So all they would have to do is just reference that output. They wouldn't have to really change dynamic too much of the code. So I'm not sure if there's some mechanism within Bicep similar to that.
I think it would depend, I guess. So one thing you could do is if you're creating all your networking resources in one module, you can output whatever that thing is going to create, so the list of subnets, and consume that in another module. So as you create more subnets, if you need to do something else based on the number of subnets, that would already be kind of coded into the other module with a loop like this. So if it's dynamic in that way and it's being created by this code base, that would, if I think I understand what you're saying correctly, that is how I would go about that. And if it's constant information, or if it's something that would be populated by like a pipeline in advance of the code executing, it may be in a JSON file, and at that point I would consume it with that load text content function, and then it would be set up so that I don't need to care what's in there as long as I know I can iterate through the list properly.
Okay, thank you.
Yeah, hopefully I'm helping, but
Yep.
I'm totally sure.
Yep. It sounds like it's the same thing. There
Cool.
would it be the equivalent? Thank you.
Yeah. Any other questions? I have one more trick up my sleeve to demo before I wrap it up.
I have one quick question. You can definitely save it to the end if you've got like some resources at the end. So when I was starting out with Azure ARM templates early on, there's this Azure Quick Start templates, GitHub repo, I believe.
Yep.
That has a lot of ARM templates where I would kind of mix and match parts from known templates that they have on those sites to stuff that we've had on our subscriptions to kind of come up with what I wanted. Do you guys have the equivalent for Bicep yet?
Yeah, we actually have started populating that very same repo with Bicep code. So wherever you, in the same spot that you would go to find a particular ARM template, there may be a Bicep equivalent there. And one thing that I've started to take advantage of is this tool called Azure Charts. And let me see if I can find Template Explorer. Here we go. So this website that I'm about to share is not produced by Microsoft. It has a way to explore all the quick start templates, and it has a little indicator if there's a Bicep equivalent in that same directory. So it can be a good way to explore what code is out there. We also have, and it may not be here forever, we built up a pretty decent library of examples in the Bicep repo. So you can also pour through those, but that's what we've moved to the quick start templates. And eventually we do want to retire this or move it into somewhere else in the repo that we just use for testing. We will eventually move it from the location that it's currently in, but a pretty good way to explore some options there as well.
Awesome, thanks.
Yep. Okay, so I did mention that we just released the Bicep private registry capability. So obviously this site.bicep is local. It's right here. And the only reason it works is because I have it represented in this file structure. But if I want to consume this from somewhere else, if I have a central Center for Cloud Excellence team that's producing assets that I can use in my projects, I may want to consume it from a central location. So what I can do is actually take this, in this case, we'll do site.bicep. I can take this file and push it to a registry and then consume it in another project. So what I'll do is I'll do bicep publish is the command, and I want to publish site.bicep. And then I have a argument called target. And the syntax is a little funky, but what I do is BR for Bicep Registry. And then I have my URL of my registry, which is actually an Azure Container Registry. There's a capability that I guess has been used for a long time, but they've since made it a pretty official thing. You can push non-container content into a registry. And there's an official spec for it now. And if you're familiar with Helm charts, those are being pushed to AC or container registries in the same way. So we're kind of been taking advantage of that to distribute this content. All that means is you stand up an instance of container registries, and then you can push content to it. So it's a.frank.azurecr.io. And then I'm going to call this Docker site. And then I give it a version. So I do colon, and then I can give it whatever version I want. I'll just call this O.1. And then I can publish it. Wait, this comes back somewhat quickly. And so that got published, and I can actually go, I happen to have the Docker extension installed, and you can load up your registries from a particular source. I'm going to load them up from Azure, and I can actually see I have in the subscription this ACR registry, and I have a couple of items here. And there's nothing that we needed to do to light this up. It all just kind of worked because we're fitting in with the specification that the container registry governing body set up. So I can see that I have this Docker site here, and it says O.1, and it says invalid because it's not a container, but gets you pretty close. So I know that this successfully uploaded, which is great. And now what I'll do to prove that I'm not cheating is I'll delete this. I set up, so this fails, which is good. I would expect that to happen. I set up an alias just to make this easier to author. So there's this concept of setting up a configuration file, and I've set up an alias that points to the same location. And this just means I can use this friendly short name when referencing. And so now when I come in here, I can change my reference a little bit, and I can do br/a.frank. And I can reference Docker site O.1, and it's going to pull in that reference, and it will validate everything in exactly the same way. So it pulls it in, puts it in a cache, and then we can do that full validation. So if I were to get rid of a required property, it would yell at me and say, hey, you need this required property, and so on and so forth. So it's pretty easy to set up a registry now, push content to it, share it broadly, and use Azure RBAC to regulate who has access. Maybe they just have read access, all that sort of good stuff that we're familiar with. So that's the whirlwind overview tour of Bicep. There is a lot more there. I'll post a link to the Learn modules. We have pretty good teaching materials by Microsoft Learn, which if you've never used before is a pretty great platform, as well as general documentation in Microsoft Docs. So I'll put links to both of those things. Here is the general documentation. Oh, getting the Google link. Here's the general documentation. And then here is the Learn documentation. So lots of good content there. If you want to go deeper, there's lots of videos on YouTube. We've been pretty happy and pretty amazed at the community kind of picking this up and running with it. So there's a lot of really great stuff out there already. Any other questions I can answer about modules, module registries, or anything else that I've walked through?
I think I may have missed one of those pieces, but like in your screenshot here, you have module site deploy, and then you have a URL, basically that's the container registry, and then the last piece is an actual Docker or a container, and then colon is the version of that container.
Correct. Yeah. Sorry, I didn't make that very clear. So this is, I think, in container parlance, this is a tag, but it's a version. So you can set this to any string that you want. We certainly encourage semantic versioning, but you don't have to do it. We're eventually going to stand up a public registry where we will have pretty strict semantic versioning for this field.
So you could have in one, say, main.bicep file, different versions of modules, and in order to pull down those modules, you have to you'll essentially be pulling down, potentially multiple containers, versus like the way Terraform kind of does it. It's like you could either have like a module repository or a repository with multiple modules. So just wondering, seems like this might be a little more heavyweight than just using Git.
I don't know. It shouldn't be. At the end of the day, what this maps to is a particular Bicep file or set of Bicep files. So if you do have multiple versions, that means that you would pull all those relevant files onto your machine. I don't know. I guess I'm struggling to see a way around that. At some point, that code needs to exist on your machine in order to resolve that reference.
To use this, do you now have to have the Docker utilities?
You do not. Yeah. All you need is the Bicep CLI, which is included in your AZ CLI. So there's only one dependency for all this stuff. Basically, we're able to use an SDK to talk to the container for you.
Yeah, great, thank you.
Mm-hmm. And from what I understand, it's not really creating a container. It's the container registry is an OCI artifact registry, so you can just shove artifacts in there. It doesn't have to be like a runnable image of any sort.
Exactly. It is not a container image. It's exactly what you said, Jason. It's an OCI artifact. I think I'm still learning how to talk about these things. So I don't know what people know about OCI artifacts. It was weird for me when I first learned about it. But yeah, it's kind of abusing container registries to shove arbitrary files in there. And so we're just shoving Bicep files into a registry.
Yeah, I shove Helm files in there when I started doing it. It's like, this seems weird, but
right.
Yeah, I get it.
It is weird, especially because you know, there's all this pre-existing history of containers, and you use this thing for containers, but now they're trying to expand it, but they're still called container registries. And so I think there's still some like friction that needs to be ironed out just from a terminology perspective, but the technology is fantastic. I mean, it works really, really well as a distribution mechanism.
Cool. It's been very helpful for me, definitely.
Cool. Any last questions? I'll talk about the roadmap as well. Cool. So let me go back to my trusty slides, and I'll talk about what's coming. So 0.4, I mentioned that's the current release that we're in. The next big releases, we have 0.5, which is relatively soon. And really the main thing that we're focused on is this public module registry. So it works just like a private registry, but we're going to populate it with content that hopefully will be helpful for getting started, making resources easier to consume with more default behavior and things like that. If you're familiar with the Terraform public registry, it's not far off from that. And then roughly January, maybe February, we're shooting for a 1.0. I mentioned that Bicep is production ready and supported by Microsoft. 1.0, in a sense, is largely a marketing exercise, but we still do want to get there. The big thing that we want to get done is have a stricter breaking change policy. So we've been a little bit loose with our breaking change policy, although not egregiously so. You'll know if there are any breaking changes coming. But we want to have a stricter policy where we only do breaking changes in major revisions. The other is we want to ship updated types separate from the core Bicep compiler. So everywhere where you're getting IntelliSense on the resources that are available and the properties that they expose, all of that comes from our type system and the available types we have for Azure resources, which are constantly being updated as new resource types exist or new API versions exist. So we want to be able to ship those separately and have them be backwards compatible. So you should be able to stay on 1.0 and get all the new type updates going forward. We're going to have a preview of this thing called Bicep Extensibility. This is the ability for Bicep and ARM to talk, or ARM deployments to talk to non-ARM resources. Really what this is about is enabling end-to-ends on Azure, which often involve things like creating a service principal or doing a Kubernetes deployment and other things like that. So we're going to start kind of dipping our toe in the water and experimenting with what we can do there. It's not ever going to be a broad provider ecosystem. That's really not the intention. We really just want to make the Azure end-to-end easier where we can, and for things like Microsoft Graph or AAD or Kubernetes, where they're really well modeled and they already work kind of declaratively already. It lends itself well to working with something like Bicep, where we can give you the same type validation and IntelliSense and all those things with those other resource types. So we're pretty interested in where this could go, but it's really a preview at this point. And then this is kind of nitty gritty, but today you can only pass simple types between modules, so strings and ints and objects. We want to actually allow you to pass resources between modules. So if you create a resource in one module, you should be able to consume that resource in another module without having to like reestablish the reference. So this is just going to make it a lot easier to work with resources across modules. And then God knows what happens after that. This will be a very nice day to get to our 1.0 release. The only other thing worth sharing is we have a newsletter that you can sign up for. ARM News. So if you want to sign up for a newsletter, we will spam you very infrequently. But the other thing that we'll tell you about if you sign up for that is our community call, which we do once a month now. where we'll talk very casually about what's kind of the latest and give the community an opportunity to get to demo things that they're interested in or working on or ask questions. It's a pretty good forum to stay involved in what's going on. And so if you sign up, we'll just put that calendar invite on your calendar automatically. And that's all that I had. Any final thoughts, questions, anything at all I can help with?
I got a couple guys typing, but I think it's pretty much just all positive feedback. Official Twitter.
Bicep Lang.
All right, Bicep Lang, got it. Yeah, all just positive feedback. Looks like.
And we're pretty good about putting updates there as well. That channel's pretty good for us. It's just really easy to reach us and pretty easy for us to push out updates. So good one to pay attention to. The other thing is, one, this is probably a lot to digest, but if you get deeper and you have more questions and you want to go back and forth, please don't hesitate to reach out. You now have the ability to reach me on Teams. Or if you'd like to set up a deep dive or anything like that with the rest of your team or something like that, we really do like to make ourselves available for those sorts of things. So please don't hesitate to reach out, and we'll do our best to accommodate that.
Awesome. Well, that has really been good. It looks like we're getting more thanks again. So I think you answered everybody's question. And it's really, really good intro level, you know, sparking the interest in me, because I've done ARM templates way too much, and they're always more complicated than they should be. So this really, really looks nice to me.
Cool.
So thanks a lot. Thanks for coming and present and doing a good job.
Awesome. Thanks again for having me, and hope to cross paths with you all in the future. Good luck to the Red Sox. The Yankees are out, so I'm encouraged. You know, it'd be great for you guys to go far.
Awesome. Well, thanks everybody, and have a good night, and we'll see you next time.
See ya.
Thank you. Take care.